Okay. So guys, as of now, we were understood t-test only, right? Okay. Still here only we would learn from the hypothesis testing. Let's talk about the Jetta test. So you already know that what exactly the t-test and jet test. Both are help you to compare your estimation and assumption, right? So here t-test, when we have a sample size is 30, or else if you don't have any information about population data, then you would like to go with the t-test. You have enough information about no you have enough information about population data, and the sample size it could be more than the 30, then that situation we would like to go with the jet test, right? So one sample jet test, in the sense we have only one group, the group population I want to compare with one particular value or specific value, then we can able to go with the one sample jet test. Okay, here one sample jet test used to test whether the mean population is less or greater or equal with some specific value. Okay, you have only one group, the group population mean you're comparing with some constant value, then that situation we can go ahead with the one sample jet test. Okay. So if you want to test, and you should have some kind of assumptions. Okay, and what could be assumptions? Mm, to test assumes the population standard. Okay, so the first assumption is that you should have information about standard deviation of the population. Okay, and so here the formula in this particular session, we would like to talk about the formula of the jet test, and what are the assumptions of the one sample jet test, and we'll have some example on that one. Okay, see, whether it is the t-test or jet-test, any hypothesis test, you should be state about null hypothesis and alternate hypothesis. And I already told you we have a two ways we can do that. One could be the one tail, and second one is the one tail, right? Two tail in the sense, so you just compare the equal, so your mean and your constant specific value is equal or not. That situation we can go ahead with the two tail jet test, or else left tail and right tail both are the one tail only. Left tail in the sense your population mean, it could be more than or equal to, okay, some constant value. That kind of situation we can have the left tail. Left tail in the sense, okay, so your mean it could be the greater than or equal to some constant value. So if this it could be satisfied, then I mean, if your null hypothesis is accepted, which means that the population mean it could be more than the your specific value. Okay, if it is rejected, then your population is less than the some specific value. Okay, for example, right tail. Right tail in the sense your mean, your population mean, it could be less than or equal to your specific value. Okay, and so here this it could be the formula for the, this is the formula for the z test. So your x bar in the sense your population mean, mu naught in the sense your value, assumption value. Okay, and this is your population standard deviation, and here n is the sample size. So here n is the sample size, and sigma is the population standard deviation, and mu 0 is the your hypothesized population mean, and x bar is the it's a sample mean, right? So with help of this values, if you should know each and every value, then you can substitute in this particular formula, you will be getting the z value. After you are getting the z value, you would like to choose the p value with, based on your significance level. Okay, so here the p value, uh, so if we have a z test value, and if we have the degree of freedom, then we can able to calculating the p value. If your p value is, if it is the less than the 0.01, okay, less than the 0.1, then which means that you should be rejecting the null hypothesis, you should accepting the alternate hypothesis. You already know this information. It is very similar to the t-test only. Okay, so these are the assumptions. Before we do the any jet test, you should check with these things actually, whether these assumptions are satisfied or not. The first assumption is data should be continuous. Okay, continuous in the sense some kind of numbers. Okay, not categorical data. And the data is simple random sample. Since you have a population, from the population you should pick up some kind of sample data, that it can be done with help of the simple random sample only. And when you distributed your data, and it could be approximately normally distributed, if and only if your data is normally distributed, then only we can do the jet test actually. Okay, and make sure that your population standard deviation must be known. Clear? Clear or not?
So, Anjan, I have a very basic question, right? Before
Yeah.
you actually do a T or a Z test, right? I mean, what are we running this test on? Is it like historical data? For example, a company who is a retailer, right? A grocery retailer has.
Anything, anything actually. Okay. Whether it is the finance or retail, whatever it is. Okay. So you have some kind of historical data. So with help of that particular historical data, okay, just assume this way. Whiteboard. You are the manager of your company. Okay. So I mean that it could be like a DMart. So they want to be estimate. Okay, so this one laptop, so laptop sales. Okay, they have laptops actually. Okay, so this laptop price you have it. So you have some kind of information about this laptop price from the last month. Okay, only 30 days of information we have it. Out of 30, they are not considering the 25 days. Okay, they are taking the every day. They have information about that specific laptop of 25 days. Okay, so that means you have only information about that particular laptop price only 25 days, the 25 samples of information you have it. But before also the laptop price you have it, right? But you don't have that information. You have only last 25 days of the laptop price information. You have it. So based upon this particular price assumption, okay, so you assumed that, for example, day one it could be the 50k, day two it was 55k, day three it was 60k, day seven it was like 35k, something. The price was variated in a day wise. Okay, now you are the you want to fix this particular price. Okay, you're not doing any kind of test. Directly you're saying that today maybe the price of this particular, some new customer came to your shop and is the price is not the price was not fixed this particular day because of time was not done actually. Okay, maybe every day 9 o'clock the price has to be fixed. Okay, but the new customer came to your shop and he is asking that what could be the price of the 8 a.m. he was asking the price. Okay, and if he wait in 1 hour, maybe the price can be reduced or increased, right? He might asking that maybe if I wait for 1 hour, the price of this laptop can be with 30k. Okay, that's his assumption. Is it clear my point? The new customer, he's assuming that if I wait for 1 hour, maybe the laptop price it could be 30k. Okay, he is assuming whether it is greater than 30k or less than 30k, you don't know, but he's assumed. By the time the data scientist or the statistician comes to the this particular problem statement, he could take this 25 days of the price of that particular laptop, and he can do the t-test. He can do the t-test. So with help of this t-test, he can apply the one tail or two tail. or two tail, let us consider two tail, because of he's saying that he is doing the bet on you. The price it exactly the 30k if I wait for that, if I wait for 1 hour, he is doing, he is betting on you. Okay, so you are doing the two tail test because of the price of the laptop which is equal to 30k, that is the assumption. Now you're taking these 25 samples and you're applying the t-test, and here we have the 25 data, 25 is your sample size, and you have the everyday price of that one, and from that one you're doing the mean of it. Okay, and with help of this 25 days of the price we are doing the mean, and the deviation standard deviation of this particular sample also you are doing actually. The n value, the sample, that sample mean, the standard deviation. Because of standard deviation also you can able to calculate it if you have a data. Okay, and you have a sample size, and this is your hypothesized assumption, right? That it could be, you can consider the mu 0. Okay, so if you know the x bar, if you know the mu 0, and if we have the standard deviation, if you know the um, n value, and we can calculate the t value, guys. Once if you calculating the t value and your alpha value, and your alpha value, for example 95% or 0.99%, I want to get it some prediction, I want to get it the 91 percentage. So 99 percentage, 99 percentage in the sense it could be alpha value will be 0.01 because of 19 0.99 something like this. Okay, so alpha value I'm considering the 0.01. So the t value and the degree of freedom. With help of these two values you calculating the p value. If this particular p value, if it is the greater than this particular value, greater than this particular value, you should say that your price of this particular laptop, it could be 30k. If it is the less than this one, you can say the price of this particular laptop, it could be not 30k actually. Clear?
Yeah, this is a good example, but I mean, the challenge here is it's only on a single attribute, right? Just a price attribute. You are doing all the tests, but
Yes.
in reality, the spec of the laptop can vary also, right? Which can change the price, right? So there could be multiple attributes variable involved. Then also you can do a T or a Z test, or is it usually done only for a single attribute?
So you're not concentrating on, okay, the what are the factors it was affected, the price. Okay, what are the factors was affected to increasing the price and everything, right? Is it clear? Okay, so that is a in-depth intuition you're doing actually. So you have only the price information. You're doing some assumption, that's it. But what are the factors? The price was affected. For that one, you should have the all the attributes like that particular weather for I mean season of that particular, okay, season, and gender who is buying more, and the configurations, okay, and everything you should be taken a lot of features actually, so that we can do with help of the machine learning. Clear my point?
Okay, 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 got it. So this is G-test. T-test is just to prove a hypothesis that you have
Hypothesis,
made.
that's
Okay,
you have some data, you don't have why that data is comes, and what are the things are affected on that particular data comes. Okay, you don't worry about it, you have some data, hypothetical data. With that but hypothetical data we are doing some kind of hypothesis testing. Okay, for example same thing, you have you don't have a 25 days actually. Maybe you're maintaining the your newly started a company with a 30 days or 2 months, 2 months back you started a company, or 2 months back you opened the store, and every day you are maintaining the information. Okay, so this is the 2 months of information, that means 60 samples you have it. But
okay,
the laptop, the price which was started in the year of 90s, right? Okay, so you have a lot of information, I mean 20-30 years of data you have it, but you're not concentrating on the 40 years of data. Okay, you have only sample size 30, and you have some kind of population mean. Okay, sorry, population standard deviation. Maybe the variation can the price of the particular laptop from the last year or before last year, you have some kind of population standard deviation. Okay, and within 30 days of standard deviation is different, and the overall standard deviation is different. Within 60 days of standard deviation is your sample standard deviation, but you have 20 years of data, right? With that particular 20 years of data, you have the okay variation, you have a standard deviation of 20 years of data, that we are considering the population standard deviation. when we have when we have the okay population standard deviation and sample size, okay, and if it is the more than the 30, then you would like to go for the G test. For the same G test, you're applying this particular formula. This is the 30k your assumption, and this is your population standard deviation, this is your sample mean, and this is your sample size. When you're uploaded, when you're substituted your values into this particular formula, you will be getting the okay Z value. Once if you have a Z value, and based upon the degree of freedom, you can able to go for calculating the p value. So this particular p value, you have some domain knowledge, right? So your alpha value, so whether it is increase or decrease, we have to compare it. Based upon that one, we can do the conclusion, right? But the same thing, this is the one example for the same laptop, okay? So this is another example. So this is your this was my example, right? In the same way, in this particular strategy, they are explaining one another example. Suppose IQ of the population is normally distributed with the mean. This is your mean, okay, 100. This is hypothesis mean, actually this is your assumption, and the standard deviation is 15, okay? So you want to be so you started some kind of new meditation. So whether if you do some kind of new meditation, whether your IQ levels can be increased, any kind of changes had happened or not, okay? So she recruits the 20 patients to use for this particular, okay, and for this particular test, actually 1 month of record and their IQ levels on the end of this particular month. So here the sample size, one sample jet test you're applying, actually. So your alpha value is it's 0.05, and this is you have only 20 samples. I already told you, if and only if we know the information about population standard deviation, we can go for either jet test, and you should go with the jet test only, even your sample size is less than the 30, okay? So here the sample size is less than the 30, but I know the standard deviation of population, okay? So your sample mean IQ value is 103, and population IQ value is population mean IQ value is 100, okay? So and the standard deviation of the standard deviation of the population is 15. So you can substitute in this particular formula, and before that one, you're stating that your H0 and HA. So your population mean which is equal to 100, your population mean which is not equal to 100, okay? So you just substituted that all values, you are getting the Z value, and so from this particular Z value, you would like to go for okay directly calculating the p value, or else so you with help of the Z table calculator, we can calculating the p value, okay? So this value we just provide over here, and whether you're doing the one tail or two tail, and you can mention the significance level, directly you're getting the p value on this from this particular internet. Or else you might have the jet table, and from that particular jet table also you can do it. Or else we can go ahead with the either R language or Python language to finding the p value in this particular jet test, okay? If it is more than or less than, based upon that one, we can do that. So same thing we can do the with help of the Python, actually, okay? So here your jet test direct function, you have it. Jet test is the direct function, okay? So this is the jet test. This is the jet test, right? So this jet test function, it can help you to find the p-value in Python programming language, which is available in a stats model. So from the stats model, we have the stats, and within that one, weight stats, and then we have the jet test. So to this particular formula, you can providing the your sample data, the entire sample data, okay? So x1 is the value of the first sample, Maybe if you're doing the two sample, then you can providing the,
Welcome to the Lunar New Year family spirit, an embodiment of the art of blending.
okay. So here, if you're doing these two samples, then we can providing the x2 value also. Your value is nothing but your mean under the null. Okay, so like what exactly you're providing the mean value, right? So that mean value we can provide it. Okay, see, simply this is my 20 patients information. Okay, 20 days or 20 patients information. So just jet test you're applying actually. This is the data you're providing and the mean value I'm considering the 100. So based up if you're providing your data and your value of the population mean, then directly this is your jet value and this is your this is your p value. So if p value is the less than greater than 0.05, right? So that your IQ value the which is 100 only. Okay, so p value not less than the 0 points. We don't have sufficient evidence to rejecting the null hypothesis, so that the new drug does not significant for the IQ level. So that means the new drug which is not affected your it's not affected your IQ. Okay, so a two sample jet test for the same two sample jet test, in the sense maybe you have a two different drugs. Okay, so this is your city or same drug. Okay, so whether it is effect on the city 1 and city 2. So no, city 1 information, I mean 20 people of information in one city and 20 people of information in another city. Okay, and so here is there, the IQ values of city 1 city 2 is the same or not. By this time you're comparing with equal, right? So that value equal to 0. So because of population mean 1 and population mean 2 equal to 0, then minus minus I mean population city minus population city, if it is equal, then that means value could be the 0, right? So that means both city populations are same. So that is my null hypothesis. If it is the more than the 0.05, then it could be evidence, but here it is the less than the 0.05, right? So that's the reason we can say that the population mean of city 1 I mean the mean value of the city 1, the mean value of the city 2 could be differ. It's not
So,
same.
if you could go back to the code, I mean, the z test here, import z test, is
Yes.
that one of the functions or classes within
Yes.
the stat
Yes.
model?
Yes.
Okay.
Stats model is the one of the library of the Python. Within that
Okay.
one, this jet test, they already created a function, just
Hmm.
providing the data what you want to do it. Okay, this
That's
is the
fine.
data. This
Okay.
is my data 1. This is my data 2, and you're providing the sample data 1. This is my sample data 2, and my null hypothesis.
Welcome to the Lunar New Year family spirit, an embodiment of the art of blending the things we love with the people we love.
Okay.
That's how they make money through all these advertisements.
Because of that one they are leaving, right? Okay, happen. Yeah, so I hope you understood, right, what exactly the one sample and one sample theoretical explanation I did it, and these are the nothing variation. The only thing is that no, when we should apply, when we should not apply, that's the only thing. Okay, so when we have a two samples and if you want to compare the means of that particular two samples, then we can able to go for the two sample jet test and make sure that both samples are independent. That is the assumption here. Okay, both populations are individuals, they're not same. both
So
pop
why this number two? I mean, why do they call it two sample? I mean, it could be multiple sample test also, right? I could
no
have
no
three
no no
cities.
no Okay, three cities, in the sense you're not comparing with the three cities, only we can compare the two groups only.
Okay.
See, this is city 1. Okay, this is city 2. This is a group 1, this is group 2, right? In a city 1, maybe 1 lakh of people are there. In a city 2, there are 2 lakh of people are there, right? Out of that one, you're taking some sample from the city 1. Out of that city 2, we are taking some sample. Okay, this is one sample and this is another sample. So that we are calling it a two sample. Clear? Clear?
Okay. Okay.
So, and this city is different and this city is different, right? Both are not same cities, right? So that's the reason these two groups are independent. Okay, so that's the reason it's a two sample jet test. So that situations only we can apply the two sample jet test. For example, one proportion jet test. So one proportion jet test used to compare an observed proportion to theoretical one. The motivation of this performing the one proportion jet test and what could be the formula behind that one, and how we can performing the one proportion jet test. See, suppose we want to know that if the proportion of the people in certain country that are favor in certain law in 60%, since there are thousands of residents in the country, it would be too costly and time consuming to go around ask each and every resident about their stance on that particular law. Okay, so what we can do, we can introduce one particular new thing. Okay, maybe some people can oppose and some people can accept, right? So I want to know that whether you so based upon that acceptance and rejection, we want to introduce that law or not, we can do this particular thing. Okay, so here, however, virtually guaranteed proportion resident in the sample who supposed in the law will be little different from the proportion of resident in entire population who suppose this particular law, and everything we can do it. You might be thinking, what could be the difference between the one sample and one proportion, right? So one sample, you're not, you're just comparing the means over here. Okay, but here some new thing, proportion. Okay, some people group up in the same country. Okay, same country, you're introducing on particular thing, whether some people can be opposed, some people can be reject, right? And the portion of the people can be opposed, some portion of people can be accept, right? So based upon the proportion, we can introduce or not that particular law and we can conclude it. Okay, so one proportion jet test always using this null hypothesis. Population proportion is equal to the some hypothesis proportion actually. Okay, it could be you can apply the two tile and we can apply the left tile, right tile, whatever it is. It could be the uh, one tile, left tile and right tile, it could be one tile proportion. Okay, this is the formula for your jet value. Now one proportion, so p minus p naught, this is p is the observed sample proportion. So you took some kind of sample, right? So from that particular sample, what observation, so that proportion, so you observe some proportion, right? That particular value. And so you're assuming something, right? Okay, your population assumption, this is your p0 and n is your sample size, and with help of that you just substituted this particular value and we can calculate it manually, or else with help of with help of the python also we can do it. So one sample proportion test with python. So in one proportion, this is the function they are going to be using to performing the one proportion jet test in Python. We use the proportions underscore jet test function from the stats model library. So this is the from this library you need to import this particular function, and we can uh, send you your count of and number of observations and the value alternate whether you're using the two-sided or one-sided, one tail or two tail. Based upon that one, we can do it actually. See, this is the just code. This is the 2 lines of code. So from the stats model and import the stats and proportion in this particular proportion. So you need to go for importing the proportions underscore jet test, and you're providing the 16. So this is your sample. So this is the proportion. Okay, this is the you are taking the 100 people, this is your sample size, and out of the 100 people, 90 people are saying your maybe the count of that particular proportion is 16. Okay, and the value, it could be no your observation, I mean your assumption, population assumption is 0.64. Maybe it was given by your domain expert. Okay, so ex resident who supposed, oh sorry, this is your observed value. Okay, out of 100, you're taking the sample size is 100, right? Out of the 100%, 64% of the people are opposing that particular, supporting that particular law. This is your 60% is your hypothesis population proportion from the entire country. Maybe 60% can be support that particular law actually, but no, whether it is support or not, and your population, it could, your population proportion, it could be 60 or not, that we can do with help of this particular thing. This is your observed proportion, and this is your observed values, total sample size, and this is your population count, population proportion supporting. Okay, so if you providing these values and we are getting the p-value, so again the statement of the p-value, whether it rejecting or accepting, could be same. It is not at all change anymore. Okay, that it could be like, one proportion. In the same way, two proportion in the sense, same law you're introducing in a two different countries. So that's the one another example. So use it to test a difference between the two population proportions. Okay, so two different countries are two different cities. So suppose we want to know if there is any difference in the proportion of residents who support certain law in country A compared to the proportion of support in the supports the law in the country B actually. Okay, same law they are introducing in two different countries, and so which country is supporting and both the countries are supporting or not, that we can simply do the test with help of the two proportion jet test. So here the so both the proportions are same, both are supporting or both are not supporting. That's our thing, statement, null hypothesis and alternate hypothesis. And this is your jet formula. This is your population 1, this is your population proportion 2. Okay, and country population to proportion, and this is your overall population, right? So here the p-value you can able to calculating based upon this particular value, p1 into n1. Here p1 is the population 1 proportion, population 2 proportion is p2, n1 is your sample size, 2 sample 1 size, n2 is the sample 2 size, and based upon these values we can calculating the p-value. So we can calculating that p-value and this p1 p2 you can substitute it, and we can get the z value, and with help of the degree of freedom we can calculate it manually on the t table. Okay, or else we can use the python code, or else r code. Two sample, two proportion, it's not shown two sample, two proportion, two proportion. Manually they're calculating. So this is the two proportion jet test. Okay, this is the count. So 5 and 12. So this country 1, this is country 2 proportions. Okay, and this is country 1 number of observation, this is country 2 number of observations, and you're simply providing that count array and number of observations count we just providing, and based upon that one you can compare the both proportions are same or not. Okay, so this is for two proportions jet test. This is for one proportion jet test. That's it. Very simple thing, nothing too much about this particular jet test and data, but it's easy things, but it's a very important as well. So try to be go for no try to be go for understanding this particular hypothesis testing today, and we can spend some time more and try to be understanding what are these particular tests are doing, okay, with my explanation, and go to this help of this particular strategy and try to get some information clear. So tomorrow we can talk about chi-square and ANOVA. So once that is done, and we can conclude the stats classes. That's for today's session, guys. Bye. Take care.